Okay, so I want to start talking about categorical statements. The things we're going to do the next few weeks, you'll sometimes hear called categorical logic. For really technical reasons, it won't be purely categorical logic. There are a couple things I want to mix in um, that aren't categorical. It doesn't really matter if you call this categorical logic, I won't care. We're going to start with categorical logic, then we'll talk about a few other things that don't quite fit in that. So, really, what we're going to be doing, you technically could call syllogistic logic. I really don't care if you get the name right or wrong on this. I don't know. Maybe I should be fussier. The whole point of logic is to be fussy sometimes. I'm not. I don't really care that much, right? But the first part of talking about syllogistic logic is to talk about categorical logic, and the first part of that is to talk about categorical statements. So, what is a categorical statement? A categorical statement relates two different groups of things. Here's an example: all cats are mammals, cats are one group of things, mammals are another. This statement tells us, well, what's the relationship between these things? Well, all the things in the cat group are also in the mammal group. Second categorical statement: some cats do not have hair. Well, this is telling us some things in this cat group are also in this group, things that don't have hair, right? This is true. You guys, I'm sure you've seen, or maybe you haven't, you've seen these hairless cats. Weird looking. I can't tell if they're like an abomination or if they're actually cute. Maybe both. Poor hairless cats, they do exist, right? So some mammals do not have hair. All cats are in the mammal group. Some cats are in the not having hair group. So some mammals are also in the not having hair group, right? Now you guys can see, hopefully, these categorical statements, putting things in these forms, allow us to see the logical relationships between these groups, between these statements, right? This is an argument here. This is a valid argument, right? If it's really true that all cats are mammals, all cats are in the mammal group, and some cats are also in the don't have hair group, then some mammals are also in the don't have hair group. If you think about this, you can see that it's valid. Three, the conclusion follows from one and two. If they are true, there is no way for three to be false. But the reason we want to talk about categorical logic is because statements that are about really different things can have the same form, right? And when we are talking about logic, we are interested in the form, right? We are interested in, you know, what this tells us. We are not interested in what we're talking about. We're interested in the form of statements, right? We know what cats and mammals are, but statements that are about things that we don't know what they are could have the same form, right? I actually don't think these are true. If you guys are studying physics, you please don't email me and tell me you're wrong, Mr. Duncan. These are not true. I know. I'm just taking the name of random particles here, right? All leptons are muons. This is saying all things in the lepton category are in the muon category. Some leptons do not have electrical charges. I don't know if that's true. I don't care. Just using it as an example. Some muons do not have electrical charges. And now you might be seeing, well, this is valid, but you might be, well, what in the world? I don't know. I'm confused. I don't know what these things are. But notice it has the same form as our cats, mammals, and hair argument, right? Both of these arguments have this all A or B, some A are not C, so some B are not C form, right? You know, some muons are not things that have electrical charges. Some cats are not things that have hair. You know, exact same form of argument. All A are B, some A are not C. All cats are mammals. Some cats are not things with hair. That's C. So some B, some mammals are not C, things with hair. Valid argument, you know, when we're talking about validity, all we care about is the form. If one is a valid argument and two has the same form as one, well, even though we are talking about very different things, the form is the same. The argument is, in fact, valid. Now, are they sound? I think the first one here with cats and mammals is sound. I guess it depends on how you define hair. But I think this is a sound one. You know, there are these hairless cats. My wife is horribly allergic to cats. She actually really likes them. She has, you know, occasionally flirted with the idea of getting a hairless cat. And I'm like, that just seems cruel with the winners we have, right? But they exist, right? I don't think the second one's sound. I actually don't think leptons are muons. I don't know. I don't care enough to look it up. So, but they're both valid. If these statements are true, the conclusion has to be true as well. And this is the form of these arguments. All A are B, some A are not C, so some B are not C. If you know that the first argument is valid, then you know any argument that has this form is also valid, because validity is all about the form. Here's another one. All cats are mammals. Some mammals lay eggs, so some cats lay eggs, right? Now, obviously, you're going to look at this and be like, of course, this is invalid, right? Premise one is true. All cats are mammals. Some mammals lay eggs. That's also true. Platypuses and echidnas lay eggs. But the conclusion, some cats lay eggs, is false, right? Unless something has changed in the last week or two that I have not heard about, no cats lay eggs, right? You look at this, and because you know what cats are, because you know what mammals are, you don't have to think too hard, well, this is not valid. It can't be, right? True premise, false conclusion. Can't be a valid argument, or that wouldn't be possible. But, you know, let's take something different, right? Again, I don't know what the myths around these things are. I'm just taking random little whatever, you know. All kobolds are pixies. Some pixies are gnomes. So some kobolds are gnomes. Is this valid? I don't know. You know, right? I guess if you've played D&D or whatever more recently than I have, maybe in that world you can tell me if this is true. I don't know. But it's not valid, right? It has the same form as our cats and eggs argument. That one's not valid. So this one is not valid either. And we can see the form of this, right? All A or B, some B or C, so some A are C, right? It's not valid in the cat argument, so we know this is not valid anywhere we see it if an argument has this form. And this is what we are trying to do with categorical syllogisms. I know these statements are somewhat artificial ways of talking. You know, people don't usually say all blank or blank. You know, sometimes maybe, but that's rare. And we're going to shove statements in these forms of all, some are not, none. That is a bit artificial, but what we are trying to do is to put statements in a form where we can see their logical form, and that will allow us to tell, are these arguments valid or not? And Even next lecture, we'll learn some pretty useful techniques for doing that. So when we're putting things in the form of categorical syllogisms, there are four. Universal affirmative, all A are B. Universal negative, no A are B. Particular affirmative, some A are B, and particular negative, some A are not B. All right. And you guys will notice if you look at Van Cleve, he uses S and P and I think Q and R sometimes. That's more traditional in logic. You will see, P's and Q's, mind your P's and Q's, I think comes from when people learn logic. Use whatever letters you want, right? I'm going to use A and B. I think that's easier. If you wanted to use S, P, R, Q, that's also fine. If you wanted to use wingdings, that's also fine, right? Point is, we're just trying to come up with kind of placeholders for these categories, because again, this is all about form, not about what things are talking about. Now, if you want to be really, really fussy about categorical logic, you are always supposed to put things in the form of all of these things are also these things, none of these things are also these things, or some of these things are also these things. And if you're doing this perfectly correctly, you would have these statements like some cats are not animals with hair, no animals are cold-blooded. Honestly, I don't think we need to be that fussy for what we're going to do. If you said some cats do not have hair, that would be fine, right? We know that that means animals with hair, right? If you say no mammals are cold-blooded, I know what that means. Even though technically, if you're going to be fussy about it, no mammals are cold-blooded animals would be better. I don't care. We don't need to be that extra. Now, in Van Cleve, he wants you to do some work translating. Like I said, you don't need to be this fussy when you do the homework. I will give you guys a note. I'm not sure that Van Cleve really emphasizes this, but here is a note on some. For categorical logic, some means at least one. One, possibly more, but at least one. And remember, we're being very, very literal with deductive logic. So this is important because this can be confusing, right? A few equals some. If you're translating ordinary English to categorical logic, a few equals some. One person out of a group, however big the group is, equals some, right? A few is at least one. One person out of a group, no matter how big it is, even if it's 1 million people, is some. Most, if I said most people blank, that would be some, right? If your options are all or some, well, even if it's a 90%, that doesn't mean all, but well, it does mean at least one. That would be literally true. We are being very literal when we do deductive logic. Practically all also equals some. Let me give you guys an example of this. And this is just, I don't know, 2 things I looked up this morning on the internet. According to Wikipedia, I don't know, Wikipedia might not always be trustworthy, but we'll just trust it here. According to Wikipedia, 96% of the citizens of Pakistan identify as Muslims, right? 96% of people in Pakistan are of this religious faith. if you picked a random person from this country, you would expect they would be a Muslim, right? That is much more likely than not. You know, contrast that with, I don't know what percentage of the citizens of Ireland are Muslims. I'm sure it's something, let's say 1 or 2%. You wouldn't expect if you picked a random Irish person for them to be a Muslim, right? They might be, but it's really unlikely. Less than 1.1, take this other statement, less than 0.1% of Americans voted for the Prohibition Party in the 2024 election. I looked this up. The Prohibition Party was on the ballot in exactly one state, Arkansas. Say no more. In the state of Arkansas, they got 1,400 votes. I forget how many people exactly voted in the 2024 election, but it was, I think, tens of millions, maybe hundreds of millions. I think it was actually hundreds of millions, right? Very, very few Americans voted for the Prohibition Party. If you picked a random American off the street, you would not expect him to have, or her to have voted for the Prohibition Party in 2024. Even if you were in Arkansas, it's pretty rare people voted for the Prohibition Party, right? I don't know. I'm amused the Prohibition Party still exists. It's like, good on you for not giving up, right? We are still going to ban alcohol. Do not see that happening, right? But why do I make this point, right? Because if you were translating these two statements, you would translate them into exactly the same categorical form. Some A are B. Some of the citizens of Pakistan are Muslims. Some A are B. Not all, right? Because you have this 4% who aren't. Some Americans voted for the Prohibition Party in the 2024 election. Well, some means at least one. 1,400 is more than one. So, some, right? We can't say all, even with our first one, because there's that 4%, so some. With the second one, more than one, so some, right? Now look, obviously we are losing a lot of information here, right? There is a huge difference between 96% and 0.01%. And you could make a lot of good inductive inferences, right? A random person in Pakistan is likely to be a Muslim, right? A random person in Ireland is likely to be Catholic, right? That's the majority religion there. But the average American, even if you go to, Little Rock or Conway or whatever town in Arkansas, is not likely to have voted for the Prohibition Party, right? Good inductive reasoning. But deductive reasoning, remember, it has to be certain in this way, right? And we are losing a tremendous amount of information here because we're talking about deductive logic and not inductive. We'll actually talk about this, when we talk about Venn diagrams, which we will in the next lecture. Venn diagrams will not work for inductive logic, not at all, because they only work in this categorical form. We will probably, I would like to get to Euler diagrams in this class. Euler diagrams will work for inductive and deductive logic. You might be thinking, aren't Euler diagrams better? Euler spelled E-U-L-E-R. Euler was German. Well, they are much harder to use. When we get to Venn diagrams in the next lecture, Venn diagrams are very precise, very rule governed. Euler diagrams are more powerful. They take a bit more thought, a bit more art to use. Venn diagrams, which we will focus on for the next couple weeks, less powerful, only work for deductive logic, but they are so rule governed that it's once you learn the rules, it's very hard to go wrong. It doesn't take a lot of intelligence or imagination to use them. Which sometimes we want things that are easy to use, even if they're not as powerful, right? All right, final note on translation. It might not be clear what type of categorical statement an ordinary English statement is. Suppose I say squirrels in North America are not red, right? In Europe, they have gray squirrels, in Europe, they have red squirrels. You know, in the US, though, we have gray squirrels. Our squirrels aren't red. You know, I think gray squirrels have actually been introduced to Europe. I guess they're out competing the red squirrels, which is sad because the red squirrels actually are cute. I've seen them. But it's interesting how Germans will talk about it, and the Brits too. The gray squirrels are more ruthless and don't play by the rules. They're more American, right? Which is funny. Not suave, refined European squirrels, right? But still, most of the squirrels in Europe are red. And as far as I know, squirrels in North America aren't. You see a squirrel in North America, it's going to be gray. But if I say that, what do I mean? Does it mean there aren't any red squirrels in North America at all? Or does it mean typically squirrels in North America are not red? I don't know. Why is this important? Because we would translate it two different ways. There aren't any red squirrels in North America means no squirrels in North America are red-colored squirrels. If we're being really precise with our categorical logic, you could just say no squirrels in North America are red. I'd be fine with that, but remember, if we're going to be really precise and extra. Or does it mean typically squirrels in North America are not red? Well, we would translate that to the vast majority of squirrels, practically all squirrels in North America are not red. That would be some squirrels in North America are not red-colored squirrels. Which of these is it? Ordinary English, it just might not be clear. You should ask the person. And this is important because which way we translate this statement will determine whether we have a valid argument or not, right? Slappy is a squirrel in North America. Squirrels in North America aren't red, so Slappy isn't red. Well, if we translate this as no squirrels in North America are red, Slappy is a squirrel in North America, it's a valid argument. Slappy is not red, right? If we translate this as some squirrels in North America are not red, Slappy is a squirrel in North America, it's not valid because some just says at least one isn't red. Could be for all this says that 99% are red. Not a valid argument, right? Now look, for purposes of this class, we will try to give people valid arguments, at least in this section. So when you are translating, if you're asked to translate an argument, try to make it valid. Ordinary English, it just might not be clear. If you're talking with somebody, you could ask them. If I said this, I might say squirrels in North America aren't red, and I might not even really think about, do I mean most or all aren't red, do I mean, who knows, right? And if you ask me, I don't know what I would say, but for our purposes, we want to make arguments valid. Now, I think one very good thing we can learn from this is just that ordinary English That's not just English. Any ordinary language is going to be vague, is going to admit of different interpretations, and whether something is a good inference or not will often depend on how we settle that vagueness. All right. Anyway, that's an introduction to categorical statements. Well, you guys might be asking, how do we use these to see if arguments are valid? There are different methods. I think the easiest one is to use Venn diagrams. That's what I'm going to start talking about in the next lecture.